Okay, advanced math. So today we're going to get into um, linear and quadratic systems. And a system is basically when you have two lines on the same graph. So as you can see here, I got a graph here. I got a straight line and I got the parabola. And that's from these two equations here. So if I go show you my calculator here, and it's going to lighten up in just a second, okay? And I might have to go back and forth a little bit with the board because the board for some reason is not touching. So when I enter these two equations into my graphing calculator, negative x squared plus 14x and x plus 22, okay, I was able to get these two graphs, and when I graphed it, it gave me and that's how I was able to draw that picture to your right. Now, if I need to, I know that my parabola was the y1, so these are my y's, okay? And what I probably need to do is making sure if we go here, I want my tables going up by 1 here. So if I go back to my table, I can see where my quadratic is going up, up. So you can see that the height roughly is roughly about at 7. All right, and then it comes down to 14. Okay. So to give us an idea of how this is going to work, we're going to kind of draw a little bit more detailed graph than the one we got here because it's just kind of hard to see. Okay, so I'm going to close this window real quick, and we're going to go. Oh, for the love. All right, so I'm going to go back and forth quite a bit here. All right, so here's our linear line. This is x plus 22, so there's 22, and I'm going every two spaces here. So that's where I got a dot. It's going to continue to go up and up and up and up and up, okay? So to help just kind of figure out idea how the quadratic's going to work, okay, I know to find my vertex point, right? That's the opposite of b over 2a, right? The opposite of b is negative 14, and 2 times a, well, a is negative 1. So negative 14 over negative 2 is 7. Well, if you remember roughly when we drew that quadratic, right? 7 was kind of the middle because it kind of that was the peak spot, right? So if I plug a 7 into the equation, so this is negative 49 plus 98. So 749 is our max, which is roughly about right there ish. Okay. So I know my one starts at 0. The other one went to 14, right? So our parabola, roughly, this is going to probably not be the greatest, but it's going to roughly kind of look like this. There we go. Okay. And what you're going to see here as we go through this is it's going to intersect at two spots. And the question is going to be, which two spots? Okay. So what I can do here is kind of take a peek. If I go back to my graphing calculator, I'm just going to turn my mouse around here so I can get to it a little bit faster and easier. Let's go to my. Again, I can use my technology and say, okay, do we share any points? Because the y1s are the quadratic, the y2s are the linear lines. So if I go down here and I keep looking, do any of these share a line? Well, if you look back at 2, they share 24, right? That means that's an intersection point. All right. So which means this point right here is 224. Okay. And if I go back to my calculator, so again, that's where they shared an intersection point. So if I continue to go down here, okay, not the same, because again, these are not the same numbers. 11 shares 33. And again, at 14, it goes to 0. So that's the only, so at 11, it's 33, which means at this point, where they intersect, is to the point 1133. Okay? So those two coordinates, 224 and 1133, would be solutions. Now, if I go back to our A here, and it's weird because now I can't touch the board anymore. So I'm doing the best I can here. But I can drag it down. That's interesting. So it says, how high will a zip line rider be when he hits the water hazard? Okay. So again, the path of the water is modeled with it. The zip line course is modeled with this. So again, he's going to hit it right at that spot, which would be, we know it's the 1133, which is 33 feet. And that's how we can answer that. Okay. So using that technology, so if we get into just the actual guts of it, how can you solve these symbolically? Okay. Just remember that the solutions are not just the x values, they're ordered pairs. So when you have two equations set to y equal, I can take these two and set them equal to each other. Okay. So now what I want to do is I want to be able to get, if I can move the 22 over by subtracting it, and then I'm going to move the x over. What does it look like we got here? It looks like we're set up, right, for a quadratic. And now the question will be, can we factor it? Well, again, when that a term is negative, right, we can factor out that -1. Okay. And now we look at the quadratic inside. Can the quadratic inside can be factored? Well, think of the factors of 22 that when you multiply them give you a positive number, when you add them give you a negative number. Well, there's -1 times -22 and -2 times -11. Well, only the -2 times the -11 adds up to 13. This adds up to -23. Okay. So our two solutions are x minus 2 and x minus 11, right? Our two binomials. So now what we're going to do is we're going to set all three equal to 0, right? Well, that doesn't equal 0, so that's kind of gone, right? And x minus 2 equals 0, and x minus 11 equals 0. So when I add 2 to both sides, and over here when I add 11 to both sides, I get those two x-intercepts, right? Well, again, if you notice, these are the same two equations that were up above in the little problem. So if I plug a 2 in for here, 2 plus 22 is 24. So that means if x is 2, the y is 24. So there's your one coordinate. And then if I plug the 11 into here, okay, so 11 squared is 121, and then you take the negative of that is -121. And 14 times 11 is 154. When I subtract 121 from 154, I get 33. So that happens to be that coordinate. And these are the two solutions, okay, to that. Okay. So now how can I graph C symbolically? Well, again, they're both y equals, so I can set the expressions equal to each other. Okay. So we want to get everything to one side. So I'm going to move the 6 over first. When I do that, I get this. And then I'm going to move the 2x over. All right, so my A term is positive, so I got to think of how I can factor this into two binomials. Well, if you think of the factors of -3, right? It could be 1 times -3 or -1 times 3. Which of these add up to 2? Because remember, 3 is a prime number, so it's this one. So our two binomials would be x minus 1 and x plus 3 equals 0. Because again, when you FOIL that, I get this. So we're going to set them both equal to 0 and solve. So x equals 1 and x equals -3. All right, so if x equals 1, and that was to this equation here, plug 1 into here. So 1 squared, you know, is 1. 4 times 1 is 4, so 1 plus 4 is 5, and 5 plus 3 is 8 when you plug that back in. So the one solution is 1, 8. Okay, and obviously this equation here is the quadratic because of the squared. This is your linear line, right? When I plug a -3 into here, well, 2 times -3 is -6, and -6 plus 6 is 0. So the coordinate for this one would be -3, 0. And these two are these solutions, which are 2 of them, to this quadratic. Okay? So that's how you can do it symbolically. The graphing calculator can help you, obviously, as well. All right, so let's go to page 2, because we got this and we got notes today, too, so there's a little bit to do. So let me click on the arrow here, since I cannot touch it. So it says we're going to write a system of equations shown at the right. So they gave us a graph at the right, and then we're going to solve it symbolically. Well, I got a linear line here, right? So I'm going to do the linear line first, all right? Because I know I have a point here and a point here. I know the slope is negative. We're going down 1, 2, 3, 4, and over 2. So I know my slope is -4 over 2, which is -2, right? So I already know right now that that's -2x. Now to try to figure out what my y-intercept is, you see that it's going to intersect the y-axis off the screen here. So this point, if I continue to go down 2 and over 1, right, because isn't that what that reduces to? So that's at the point -2, and if I go down 2 more and over 1, that's -4. I got to go down 2 more and over 1, so that puts me at -6. So -6 is so there's our linear model, right? So I got our equation for the linear line, okay? And hopefully I get it right, because remember, these two lines share these 2 points. That way we'll know we got our equations right if the 2 points match up. So now let's look at our parabola. Well, we know that it's got to be going upwards, right? Okay. The minimum point is on the x-axis at 3, right? -3, I'm sorry. So if you think about how x equals -3, if you add 3 to both sides, right, you get x plus 3 equals 0, remember? And we set that equal to both sides. Well, that's usually when you have something like this, right, because they're both -3. All right, so x plus 3 squared that's x squared plus 6x plus 9, okay? So you kind of say we did that backwards. Because remember, the solutions that you factor are the ones that touch the x-axis, and it touches at -3, which means your 2 binomials have to be x plus 3 squared, the same thing, okay? And I'll just kind of write that. So now if we try to solve this by what we call substitution, or we're gonna set these two equal to each other because they're both y equals, and we call this a substitution method. You learned this last year in systems of linear equations when there's a method you could do. Now we're doing it with a linear and a quadratic. All right, well, again, I can add the 2x to both sides. We're just gonna combine, and we're gonna add the 6 to both sides. Okay, so that's gone, leaving me 0. And this is gonna be x squared plus 8x plus 15. Okay, now I gotta think. Okay, now I got to think, how can I factor 15? Well, I got to think of the factors of 15. Okay, 1 and 15, 3 and 5. That's about it, right? Which of those add up to 8, which is our middle term? 3 and 5, right? So you're going to have x plus 3 and x plus 5. So now we set them both equal to 0. This board is giving me all kinds of problems. I'm going to subtract 3 to both sides, so I get x equals negative 3 and x equals negative 5. Okay. So if I go back up here, okay, and what if I just use my linear line, since that line's easier, okay? If I take negative 5 and plug it in, negative 2 times negative 5 is 10. And 10 minus 6 is 4, right? So that would mean this point is negative 5, 4. Well, if you look, all right, here's negative 2. There's negative 4. Negative 5 is right here. And if you look up there, there is negative 5, 4. So we got one right. Now, hopefully the other one is this negative 3, 0. So if I plug in the other solution to the and again, I can just pick one of them. If you use the quadratic, you get the same thing. So negative 2 times negative 3 is 6, and 6 minus 6 is 0. That gives you the point negative 3, 0, which you can see the two solutions check because that point is negative 3, 0. Oop. And yeah, this is lots of fun right now. All right, so you can tell that those solutions were right because these are the two solutions on the graph that intersect each other with that linear line in the quadratic. Okay. Now E, if we try to show this graphically, let's see if we can make this graph maybe a little bit bigger. Since we got a little bit more room. Let's see if that helps us here a little bit. All right, well, I have negative, if I look at just the linear one, right, I know the y-intercept is at 4. Okay, which is this point right here. So I'll just I'll go up just a few more. You gotta be kidding me, right? We are having all kinds of issues with our H drives and stuff, and that's why it's screwing up my board. Because I can touch and move lines around, but I can't touch and move. Yeah, this is good time. So my slope is negative 4, which means if I go down 4 and over 1, that puts me right here, right? Okay. So if that puts me right there, I got a line. And I don't know if we'll see if it'll let me draw a straight line, because for some reason I can't touch this board. All right. Let's see if I can make the line a different color here and see if I can let me go right through these points. This is so much fun. Okay, so that goes right through the point 0, 4, and 1, 0. Okay, so there's my straight line. Now, if I look at my quadratic, okay, which I know by staring at this, and I've been doing this for a while, but this is x minus 5 and x minus 1. Okay, because I know that negative 5 plus negative 1 is 6, and negative 5 times negative 1 is 5. So that means my two solutions would be 5 and 1, which is right there and right there. Now we know that our vertex is the opposite of B, right? So B is negative 6. The opposite of B is 6 over 2A. So that's 3. So 3 is our vertex. There's our line of symmetry. And if I plug a 3 in up here, I know that 3 squared is 9. Minus 6 times 3 is 18. Plus 5 is, let's see, negative 4. So roughly about right there. And I would kind of look something like that. Although it's not going to go inside, it's probably going to go outside this thing here. Yeah, I kind of drew this a little incorrectly because this is going to kind of continue like that or something. So there's an intersection point over here somewhere. Okay, you can see it graphically. It's a crummy graph, but you can see it. All right, so to figure out what it is symbolically, because again, we probably need our graphing calculator to see what the numbers would be on the graph, but we can also do this symbolically by taking these two and setting them equal to each other. All right, if I add the 4x and subtract the 4, I get that. All right, and I know that if I got my my C is 1, so the multiples of 1 are just 1. To get to negative 2, this would have to be negative 1 times negative 1, right? So this is going to be x minus 1 times x minus 1, or x minus 1 squared, right? So when I set them both equal to 0, I got the same x-intercept, which is right there. Because if x is 1, if I plug in a 1, negative 4 times 1 is negative 4, plus 4 is 0, y equals 0. They're both going to equal that. All right, so our 2 points end up to be the 1, 0, which is this. So it only shares the 1 point, which is right here. So this really doesn't go up. This kind of will continue to go up, but it won't touch the y because this widens out. So it's never going to hit this line again. So again, its shared point is 1, 0, which is our solution. So again, that's how symbology can kind of help us see that. All right. Now the last part, part F, show the process to solve symbolically. They give us the two equations. Now it says the solutions are, so it gives us the answers. Okay. So if we show the process symbolically, you set these two equal to each other. Okay. And by doing that, if I move the x over, and the 1. Okay, so now I got to put my thinking cap on how we can factor this. Well, think about it from a little while back. We could use an area model, right? If I know this is 2x squared and this is 5, but when I add the two diagonals together, it has to be negative 11, right? So I know that x and 2x gives me 2x squared. But my 5s are going to have to be negatives to get there because I got to get the middle term negative, right? Well, 5s are 1 and 5, right? So if I make this negative 5 and that negative 1, I got negative x here and negative 10x here. And that gets me my negative 11x. So my factor would be 2x minus 1 and x minus 5. So when I set them equal to 0, add 1 to both sides, divide by 2. So x equals a half or 0.5. And the other one, we add 5 to both sides, x equals 5. All right, so we got 2 to the 3. So now we're going to use the linear one. So if I plug a half into that, y equals 1.5. So that one solution is the 0.5, 1.5. Voila, there it is. And then if I take my 5 and plug it in to x, y equals 6, and there is your 5, 6. So there is the other solution here and there. And that's how we can solve that symbolically. So just a little exploring. We're going to do some notes in a minute too. But that was a little exploration with your system of linear quadratic systems. So let me stop this video here.